All right, hello. Today we're going to be talking about serial addition, and we're going to be doing that using 4-bit shifters. All right. And in this lesson, we're going to be adding two numbers together. We're going to be adding, for our OGN, we're going to have a value of 9. And for our addend, we're going to have a value of 11. So we're having 1001 for our OGN and 1011 for our addend. All right. So here is our table for the step-by-step process of how these 4-bit shift registers are going to be working. All right. So first, in our first phase, we're going to make sure everything is clear, that all the registers have no values and that our D flip-flop doesn't have any carry-in value. All right. And once those are clear, we can load in our OGN. We're going to be loading in values from the least significant bit first and then the most significant bit last. All right. And then for our next phase, we're going to be loading in our addend. And while we are loading in our addend into register B, which is one of the shift register that we're loading our values in, as we're loading in our addend, our OGN will automatically be transferring to register A, this 4-bit shift register here. All right. So as you can see, we have 1001 loaded into our OGN, and as we go to phase 3, we're loading in the least significant bit for this value here, 11. So our least significant bit is going to be a 1. So you can see we have 1 being added into register B, and then everything gets shifted over. We have 1001 initially, and then you can see the 1001 here, where that least significant bit got shifted over into this 4-bit shift register here. All right. And that process keeps going on, shifting over from register B to register A while we are loading in our new number into register B, all the way up into the point where you could see we have our two final values. And here we have 1011 in register B, and we have 9 here in register A. Okay, so once we have our two numbers loaded into our registers, all we have to do is make sure we're not adding any serial in values, and just go ahead 4 more pulses to add A and B. So here's where things get a little bit more complicated, but not so much at the same time. We are going to be adding A and B, and we're also going to have to worry about a C in value, as we adding bit values can always carry in very easily. So our first addition is a 1 and a 1. So 1 and a 1 will result in a 0, and that gets transferred over. And we have a carry in of 1 for the next addition. So, and that ends up as a 1, which carries into the next value, and we get a 0 here, and that carries in a 0 for the next one. And then performing the last addition, we have a carry out bit of 1 here. So that's very important, this carry out bit, as our result will not be very, very accurate here. You can see we're adding a value of 11 and a value of 9 together, which gives us 20. And you can see here in our final addition, we have a value not of 20. We have 0100, which is a 4, which is not right. But if you consider that if we had a carry in position here of 1 in this bit position here, in the 5th bit position, that would be a value of 16 plus 4, which is 20. And 11 plus 9 is 20 here. So that is this little value here. So let's go ahead and move on from our table and check out how this ends up working out overall in Logisim. So here is what we have. Whoops. And whoops again. Here is our device. I'll go ahead, full screen this. Zoom in a little bit more. And so again, our first step is to clear everything. So I'm going to clear and cycle the clock. All right. Now we are ready to go. So again, our first value that we have to add into our OGN was 9. So first thing is first, we're going to load in a 9 by least significant bit first. So we're going to add a 1 there. And then we're going to add a 0 and a 0 and then a 1. So you can see here in our B register, we have a value of 9. All right. And now we want to load in our next value, which is 11, into register B. And as we're loading in those bits into B, these bits here, one by one, will get transferred into this register here. So let's go ahead and add 11. So our least significant bit first is a 1. And you can see our first value from our AUGN got transferred. All right. Our next bit value is also a 1. And then next one is a 0. And then final one is a 1. So here we go. We can see that we have a 9 up in register A, and then we have a value of 11 in register B. Next thing to do is make sure our serial in is turned off and cycle the clock 4 more times to perform the addition. And take note of this D flip-flop here. Anytime you see a 1, that's going to represent a carry out value. So as you can see, we'll have 1, 2, 3 cases where our carry in value will show up into the D flip-flop and perform in our addition. So most importantly, this last carry in value, like I was talking about earlier, is the most important because this value is it has to be attached to the register A value where our final answer will be, because that will make it correct. Otherwise, it will not be. So let's go ahead and cycle the clock 4 more times and see what happens. So our first clock cycle through, we have a carry in value. For the second time, we'll also have a carry in. The third time, we shouldn't. Perfect. And our last time, we should. So this is our 5th bit value of 16. And then we have a bit value of 4. 20 is our answer here, and which is correct. 9 plus 11 is 20. So there we go. That is how this serial adder works using 4-bit shifters. Thank you for watching, and tune in next time.